So we're having some technical difficulties here. We have the positive power of quotient property, which on the last video we had finished up. I had expanded 3/5 raised to the 4th power. We can see that each base is raised to that power. We finished with 3 to the 4th and 5 to the 4th. Okay? And I could evaluate those numbers. Okay? Now, with variables, if I have a divided by b raised to the nth power, each base will be raised to that power. So I have a to the nth and b to the nth. Okay? Now, this example here, we have 2x cubed divided by yz, all raised to the 3rd power. Now within this, you have to remember that a power to a power property, you have to multiply exponents. And this is very similar to distributive property with exponents. So you can see here that we have 2 raised to the 3rd, x raised to the 3rd, and also to the 3rd, so that's 3 times 3, we get x to the 9th. Y is raised to the 3rd, and z is raised to the 3rd. All right? Now, here's an example for you to try. We have a times b to the 4th divided by c squared d cubed, all raised to the 2nd power.
Bruno Everest, your ride is waiting for you.
So remember, distribute the square, the power of 2, to each base. Each base will be raised to that power. Remember here, a power to a power. Multiply. All right, now we're going to finish up. We have the negative power of a quotient property. All right, now the negative quotient power property is very similar. All right, here we're going to have a quotient raised to a negative power equals the reciprocal, got to remember what that means, reciprocal of the quotient raised to that power. So the only change here is that we have to use the reciprocal of the quotient. Okay? The reciprocal of the quotient. So we're just going to have to flip that fraction. So what does it look like with numbers? Alright, so if we had 2/3, there's our quotient, raised to the power of -4, it's going to be equal to the reciprocal. Reciprocal of 2/3 should be 3/2, raised to that power, but it's going to be positive. I left that out. So it's now raised to the 4th. Okay? And if we remember before with the positive power property, that means each base is raised to that power, so we really have 3 to the 4th divided by 2 to the 4th. All right, so let's see it with algebra. Or with variables, I should say. All right, so if we have a quotient a divided by b, and we're raised to the negative nth power, a quotient raised to a negative power equals the reciprocal of the quotient. So we're going to have to flip a divided by b. It now becomes b divided by a. And it's raised to that power, but it's going to be positive. So it's now to the positive power of n. And if we remember the power positive property, we have b to the nth divided by a to the nth. Each base raised to that power. All right, so let's look at an example so you can give it a try. So let's say, for instance, we have 3x divided by y squared, all raised to the -3rd power. All right, so a quotient raised to a negative power equals the reciprocal. So the reciprocal of 3x divided by y squared would be y squared divided by 3x. Raised to that power, but it's going to be positive. So we're now to the power of 3. Just like before, quotient raised to a positive power each base is raised to that power. So remember, power of a power property, multiply, you're going to start off with 2 times 3, so you have y to the 6th divided by 3 to the 3rd times x to the 3rd. And I could figure out what 3 to the 3rd is, because I know 3 times 3 is 9, and 9 times 3 is 27. So really I could take that a step further and say y to the 6th divided by 27x cubed. Alright? Now, finally, I got to let you go. Try one on your own. Let's try the quotient of 2x divided by 3y raised to the negative power of 2. Good luck.